Welcome to today's webinar, and we're pretty excited because we're introducing a new product today. It's our FlowZ product, and we'll kind of go through what the key functions are of FlowZ and why it's differentiated in the market. So today I have Vince Ray, our CTO and co-founder, and I'm Dustin Froyum, co-founder of VirtualZ Computing. Let's go through a little bit of our agenda here. This is being recorded and will be available for playback on our YouTube channel or on our Skyward Data podcast, and that's available on all typical podcast channels. And then we'll get into FlowZ, the introduction about what it does and what it is, the architecture, some of the things that distinguishes FlowZ in the marketplace. Then we'll cover some of the use cases that you can address with deployment options, and we'll highlight a partner that we work closely with in that. And then we actually have a demo of FlowZ that we'll play for you, and then we'll go through the pricing, some Q&A, and we'll get out of here. All right, Vince. So let's dig into a little bit about FlowZ itself. Can you just kind of describe what FlowZ is and maybe touch on how it differs from what we've brought to market to date?
Yeah, so in my mind, FlowZ kind of fills an obvious need out there where what you want is mainframe applications either sharing cloud data or writing to the cloud in a way that's just drop dead simple to use, that can support any cloud that you might have, maybe even many concurrently in parallel. Those are hard things to do today, and that's why we brought FlowZ to the market. Now, it's conceptually similar to our Zaac product, which does many of the same things, but Zaac is based on the idea of supporting every possible type of I/O on the mainframe. So if I want a vSAM file backed by Amazon storage, I can do that with Zaac. It creates what we call virtual disk volumes in the cloud, and those virtual disk volumes behave just like physical disk volumes. So you can use them exactly the same way that you would use any other type of physical mainframe disk. The problem with that is it creates a little bit of complexity. If you've got that need, of course, that's what you're going to do. But a lot of times, your needs are much simpler than that. Your needs are, I just want to back up some data to the cloud, or, I have an application that I run, God knows where in the cloud. It's going to create some files that I need to process in a mainframe application. If your needs are simple like that, then FlowZ fits perfectly. The way FlowZ works is, instead of virtual disk volumes, what we create are they're file system objects. They're things that you see on your mainframe that look and behave like files. But instead of opening and doing I/O to them and working against mainframe data, when you reference one of these endpoints, it's been bound to a particular cloud target. So, just as an example, I might set up something called, my backup, and then run a backup utility outputting to that file. And what I'm really doing is writing to, an NFS server in the data center, or Google Cloud Storage, or whatever my favorite environment is. So because of that, fact that there's not a virtual disk it's really, the sky's the limit in terms of what you can do with this. Number one, we don't have to impose any capacity limits. With the virtual disk approach, the virtual disk file is the size of a normal mainframe disk volume. So, if I need to write a terabyte of data, I probably have many, many volumes. With flows, it's not like that. It's more of a sequential process. And that file could be as big as, whatever the cloud provider allows you to have. If it lets you write, terabytes in a single file, you're welcome to write terabytes in a single file. It's also bidirectional. It also enables sharing. So, in other words, with the virtual disk approach, that thing that, if you could look in the cloud and see what we've created there, it's, one file that basically looks internally like a mainframe disk. That means if you wanted to, let's say read a file out of that on, some other platform, you'd have to understand the structure of that disk, and that's kind of a tall order for a lot of folks. With flows, the data that you get in the cloud is kind of one for one what you put into it. So if I write records into it, that file that's created could be opened and processed by an application anywhere. And by the way, that goes both ways. It's not just mainframe data written to the cloud. Mainframe application can read data that, maybe you have, I don't know, Salesforce.com or Workday, and you get a bunch of records exported out of one of those products, and you put that in an Amazon S3 bucket. With flows, I can just point to that bucket and read that data, and it's going to come out in a nice sequential format for me. So, much easier to do application sharing that way. And then again, it's not, it's real time. You're not staging anything. You're not, many approaches you would run that mainframe application, write the data to, somewhere on your mainframe, and then you would ETL that data into where you need it. This isn't like that. This is, record by record as you're writing data. It never exists on the mainframe. It's sent in real time to the target. So there's no need for the staging. There's no need for that whole ETL process. All of that just kind of uh, really vanishes as kind of an operational hurdle there. And as I said, I could write as much data or as little data as I need to. Just as an example of that, and I do a lot of my development work on an IBM Z PDT system. It's for those of you who might not know what that is. It's basically ZOS that runs on a an emulator that runs on basically a big Linux PC. So, I'm kind of constrained compared to most mainframes how much storage I have, and things like backing that system up and that type of thing have always been problematic for me. I'm able to use flows with normal disk backup software, and instead of going to a local file, I go to a variety of different places. So very flexible that way. It could be, as you see on the slide here, it could be on-prem, it could be in the cloud, it could be combinations, really anything you want. And as I hinted, there's no change at all to the application. The ZOS application still sees what it views as a file. It does normal open, close, read, write, and when it accesses data, it's actually accessing remote data based on whatever configuration you set up. So the other, and this is a really important point too. A lot of times when we talk about data sharing with other platforms, customers will tell us that it takes them weeks, months, in some cases years to figure out all of the little details and resolve all of that. With something like flows, I mean, literally you could be up and running in an hour. The software is trivial to install. The only thing we require is a little bit of configuration, which is basically where's your target? What do you want to talk to? Is it Google? Is it an NFS server in your data center? What's the target? And here are the credentials I need to supply to connect to that. And from that, you're up and running. there's no code. There's, it's not like a lot of ETL solutions where you're going to write application logic or APIs or any of that. It's, totally open that way. And, generally the performance is quite amazing. Certainly it's going to depend on what the cloud provider offers. But, just as an example, if we use like an on-prem network attached storage device, we can back up mainframe disk volumes literally in seconds to the cloud that way. So, it's, again, it's a big difference between many of the competing technologies where, you might sit down and provide APIs, and maybe those APIs are using HTTP transactions. And, so there's a whole layer of text and, JSON or XML parsing, and, on and on and on and on that way. In our case, if the target supports it, and, NFS is a good example. If it's got an efficient, network protocol that's really designed for file sharing, we exploit that. That means really big buffers. That means, streaming massive amounts of data. That's, a binary protocol that doesn't require, text. All of that tends to really accelerate the process quite a bit. So, every cloud target will be a little bit different that way. A lot depends, as I said, on what the cloud provider supports. But if they support sophisticated, ways of doing, bulk data operations, generally we support that too. And by the way, I'll just mention quickly in passing, one of the other advantages of FlowZ is that our, that back end piece, the part that actually knows how to talk to, Google and Azure and AWS, or, whatever it is, that's open. And what that means is that, we could share the standard for that, and anybody could write a driver that plugs into FlowZ. So you're not limited to the things that we decide to support. Certainly we'll support everything we think our customers want, but if you've got an unusual or really unique use case, it's not difficult to extend FlowZ to support anything you might want to connect to. So anyway, let me stop there, Dusty. What did I miss? You always ask good hard questions.
Yeah, so Vince, this is really our first time talking about this, so I've got lots of questions, and so I'm gonna pepper you with some as we go. But let's start with the architecture one. FlowZ sits on the mainframe. Do we require any code on the target? The SAN, the NAS, in the cloud, anywhere on the target side, or is it all self-contained in the mainframe?
Yeah, no, our model is entirely self-contained on the mainframe. The only thing you need is FlowZ itself installed in your ZOS system, and, whatever drivers you want to use configured to talk to the targets you want. In every case, we connect, we are, talking directly to the target and doing standard things that the target knows how to handle, like NFS operations or Google Cloud Platform API calls, or, whatever it takes. We do it all from ZOS.
And then, so thank you, because I think that, as I understand other options in the market, that's a pretty big distinguishing factor. And, obviously the ease of deployment as well for that. So on the mainframe side, you can use this with any of your backup programs or utilities. Is that right?
Yeah, that's,
Any that,
I mean, certainly we haven't tested every last one, but
yeah.
Just as an example, I mentioned I do this. I use IBM's DFDSS dump restore application, which is pretty standard for ZOS. We provide uh, I shouldn't say, I don't even know how to describe it. We provide an optimized version of that works best with flows, and that's all it takes. Standard syntax. If you've got existing JCL doing that, basically just by changing the target, you're able to redirect that data into flows.
And then what's the install like for, it's mainframe only. What's the install like? What's the timeline like for that, Vince?
Yeah, the installation is almost trivial. I mean, we provide the software in a compressed archive format. You would restore that to ZOS Unix services directory, and it's pretty much ready to run at that point. There's a couple of optional things. We give you a way of controlling which of your users is allowed to use flows. So if you want to take advantage of that, there are security permissions and that sort of thing that need to be done. But that type of configuration is very straightforward that way. Also we at least in my experience in actually using the software hands-on, where I typically spend most of my time is just figuring out what do I want to connect to, what credentials do I need to connect to that target, and how do I get them? So in the Google environment, for instance, what I find to be most straightforward is I'll go into my Google account, I'll create Google calls it a service account, which is basically a small document that has my credentials in it. I can import that into Flows, and that's basically what Flows will use to authenticate to Google. Every system is a little bit different that way, but usually that's where the challenge is. And of course, it probably goes without saying, you need network access to the target that you're going to talk to. Some sites have locked down their mainframe so thoroughly it's not allowed to make outbound connections to Amazon or Google or Azure or whatever else you're trying to use. So you may have that kind of setup also, where you would need to have your network administrator open those outbound connections so that flows can use them. So yeah, I mean, it's a knowledgeable mainframe user who has the ability to do the types of things that I'm talking about could easily do this kind of thing in minutes. It's not like an all-day thing. It's not the kind of thing that goes for weeks and weeks. It's the basic setup and installation is pretty trivial. You'll see that in the demo as well. I mean, it's relatively small amount of software, very focused on just solving this problem and in an innovative way, and doesn't require a lot from the user. And I want to be clear, if you have the need for more than that and you're looking at like our Zaac product, a lot of that is shared. A lot of it is, you could think of flows as, for instance, the drivers that we use are shared with Zaac. So that means the credentials and all that other stuff that you set up will be the same for both products. The difference is because Zaac is doing more of that virtual disk emulation, there's more setup work there to do to make sure that you have device addresses in your system and understand the device types and how big they are, and that kind of stuff gets to be part of it too. That's an easy process too. It's just that Flows is much simpler even than that.
Okay, Vince, two quick hitter architecture questions.
Hmm?
So if you were going to implement, the highest performing version of flows, what would you do?
I mean, if I'm just looking for the fastest possible thing. In my experience, it's going to be something on-prem. Um, so something like a SAN environment or something like that. And honestly, beyond that, as long as I have maximum uh, 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 bandwidth to it and I'm configured properly that way, all of those devices are just blindingly fast. I mean, it's been a surprise to me. Many of them are nearly as fast as reading local mainframe disk. So that's that. If you just need super big pipe to push data off of your mainframe, or even going the other way to suck data into your mainframe, that would be the right answer. The cloud providers are, in my experience, they're all good at certain things, not so good at other things. Uh, you know, AWS, and I don't necessarily mean to uh, attack anyone here, but they tend to be slow in the data ingestion, but they're really good at replication and encryption and all of the things once the data gets there. Google is probably the other way around. It's very efficient to get data to them. Especially if you've got the use case where you're like appending data to an existing file all the time. Maybe you have a log file of some sort, and your model is, I don't know, once an hour you open it, append the data, and close it. That tends to work way better in a Google environment, or in an Azure environment. In Amazon, that's more of a challenge, but as I said, there'd be other trade-offs that make that data easier to manage, secure, replicate all of that stuff once it gets there. So there, at least in my opinion, there's no single best answer all the time. It depends what your needs are. And we're talking capability here. Certainly there are cost differences when we start to look at some of these things. So, I imagine what I would do in my data center is I would build out a little matrix of the cost, the capability, what else I'm doing with these different cloud providers, and that would probably steer me to what I wanted to use. But again, and the other really important thing to realize is that the best answer today might not be the best answer tomorrow.
Yeah.
So and again, that's one of the beauties of flows, is that there's nothing in your software that binds you to a particular target. If I'm doing, I don't know, on-prem stuff today, and tomorrow I want to go to AWS or GCP, all I do is change some configuration data, and now I'm doing that. So, you're able to kind of almost arbitrage these differences over time as better options start to appear out there. So, yeah.
So Vince, are you doing today? Are you doing NFS to your on-prem SAN?
Today I'm doing mostly NFS to
Yeah.
my SAN. I did set up a version of it that basically speaks the Amazon protocol. I just in my particular case, I found the NFS piece was better, and I didn't get any advantage of the other things that the S3 implementation could do. So for now at least, I've set up, and I'm pretty happy with the S3 version.
Yeah, you already kind of answered my second question. You intuited to it, which was I was going to ask you if you were going to do, kind of the lowest cost long-term storage, what would you do? And you kind of talked about that with the matrix and kind of lining that up. So let's
Yeah.
talk a little bit about, sorry, I didn't mean to interrupt you, Vince. Were you going to say something else?
No, I mean where that also gets cloudy is just as an example, the NFS server that I'm speaking to itself has features to replicate to a cloud provider. So it gets to be an interesting question. Do I do better to write locally and then let their software go to whatever cloud target I want, or do I go directly to the cloud target? Or there are many, many possible configurations there, and they all have different strengths and weaknesses. It's and the flip side of this, though, is that this might be new for mainframe customers, but people have been dealing with this for, at least a decade across all kinds of other platforms. So the decisions you probably are making on Windows or Linux or, whatever other environments you got probably carry over to the mainframe. You probably answered these questions internally on, every other platform you run, and there's no reason to think you should be doing radically different things on the mainframe.
Thanks, Vince. We've talked a lot about kind of the backup use case, but let's just touch on the data sharing piece. So can you just kind of walk us through that? Give us an example of how flows can kind of facilitate that. You've got a whole list of stuff here. I don't know, pick one of your favorites, or your favorite use case, Vince, and just kind of, can you just talk us through that and how flows works in that?
Yeah, in my experience, there are really a couple of different basic patterns here. One pattern is I've got a copy of the data on my mainframe, and it's almost an ETL approach. I take that data, transform it somehow, and put it somewhere else. And of course, the challenge with that is keeping it all synchronized as it's being updated. You have agility issues, you have fault tolerance issues, or all kinds of challenges with that. The second approach is more of a shared resource model where, I decide. It doesn't matter whether I decide to keep the data on my mainframe. And by the way, that would be our FlowZ product. If I want to keep the data on the mainframe and that's the single source of truth, I use FlowZ for that. And then other applications have real-time access to my mainframe data. If I want to go the other way, if I want to keep the data in the cloud, that's where products like FlowZ fit in. So basically what we're saying is, instead of replicating, you just provide the mainframe application with remote access to non-mainframe data. And that allows you to kind of sidestep that whole issue of ETL and replication and how do I keep things in sync. Again, there's only one copy of the data with flows. It's wherever you configure it to be. So that makes it usable for a lot of different things. It's not some of these are really, really simple. If I've got like a text file and I just need to share that with some other platform, an application on some other platform, I push that through FlowZ. FlowZ has some built-in data transformation capabilities. If I know that that's just EBCDIC records on my mainframe, I can transform that to ASCII or UTF-8 or whatever code pages my other applications on other platforms are expecting. It couldn't be simpler to do that kind of thing. And that works really, really well because, as I said, it avoids all of that complexity of how do I keep two different things in sync across two different platforms. So now, again, I think this is the value prop for VirtualZ. We can give you many different ways of doing that. A lot depends on what do you want that target application to see. Is it a file approach? Well, that would be FlowZ, as we're talking here. If your distributed application would rather process that data with SQL or on a database somehow, that would be our PropelZ product. But it's basically a similar concept. I take mainframe data, it gets written and it gets stored in a format that a non-mainframe application can make use out of it. So, a lot of that really just comes down to the specifics of what does the application want to do? Does it want to deal with files? Does it want to deal with databases? Does it want to, is it writing data that I need to consume on the mainframe side? Uh, we have examples where we take mainframe data, we use our data transformation capability to transform it into JSON or XML or CSV format, whatever you need, and then push that through flows to the target. So, the sky's the limit in terms of what the possibilities are. They all run really well. They're all really scalable and very simple to deal with because they don't require application changes. They don't require coding. They don't require really anything other than I have this data. I want it to get to this target, and we handle the rest for you. So it's definitely an open-ended thing. And by the way, that's a lot of what Dusty, as you know, what we do is just work with customers and prospects on what's the best way to get this from A to B. And we're happy to engage like that.
Yeah,
So
well, thanks,
go ahead.
Vince. I'll share one, one of the kind of real world use cases for flows that I'm working with. So this customer had recently gone through a data center modernization and re-architecture. And so basically they went from a toggled, I don't know, I don't recall what the frequency of their toggle is, but essentially they have two production data centers, right? One's live, the other one's backing it up, kind of classic IBM, XRC, PPRC, data replication. But they need to have additional copies for resiliency, data resiliency, in case those primary copies that are replicated essentially synchronously get corrupted. There's some issue with them, and so they wanted a way to have tertiary quaternary copies of the data without having to have a third mainframe data center, right, with additional DASD, coupling facilities, et cetera. So that customer is um, looking at flows for that particular purpose because of the ease of implementation, the flexibility to the targets, how fast they can implement it as well. So just kind of a real world example. Again, back to the backup scenario, which is, just a prime use case for this. And I'll just mention, I'll put a plug in right now. So we're going to do a future webinar and podcast on the EU regulation DORA and some of the Article 12 requirements for resiliency there. That FlowZ is uniquely positioned to help those EU customers comply with the Article 12 requirements for DORA. So keep your eye out for that. Yeah, so these are just examples of, this is a on-prem version. I think we've kind of talked through that in your example, Vince, right, with SAN or NAS. Obviously, you could have on-prem cloud storage like Outpost. And then also there is, kind of the SaaS version with one of our partners, Polera. We've got some really great partners in this space as well. So check out our partner page and you can see if there's a partner there you're already working with, or just reach out to us and we'll be glad to talk through. We work with just about anybody, so we're happy to make this work for who your preferred partners are. But this is kind of the SaaS view of instant mainframe storage in particular. Okay, Vince, we're running a little long. I think let's hit the demo, and maybe that'll lead to some additional questions here. So let me play this. Hopefully the audio's okay.
Welcome to the VirtualZ FlowZ demo. FlowZ is a exciting new mainframe software product that we've developed, and what it does in a nutshell is it makes it very simple, very straightforward to get mainframe data to just about anywhere, whether cloud applications, network attached storage devices, just about anywhere. So we don't usually talk about the installation process, but I just wanted to spend a minute on that and show how simple it is. What you see is just a normal shell session on my mainframe. I have the FlowZ distribution, as you can see, and all it takes is a single pax command, to explode that archive. It runs, and you'll see a directory structure, such as on the video. This is the FlowZ product is pretty much ready to go like this, and as you saw, it can be installed literally in seconds. So when we talk about you can be productive, the same day you receive the package, we're not exaggerating. It's one of the easiest bits of mainframe software you'll ever deal with. Now, in the demo today, what we're going to look at is we're going to be sharing some mainframe data with a SAN environment, and in this case, I have a physical SAN device that's set up to be network accessible to my ZOS system. What we're looking at here is basically the control panel or the desktop that comes with the software. In this case, it's running right in my browser. And what I've done up to this point is I've just configured it to have an NFS link to my mainframe. So what I'm going to do now is I'm going to go into the various shared directories and I'm going to create a new one. I'm going to create a folder that I'm just going to call FlowZ. And, of course, it could be named anything. You could do this a lot of different ways. This is just one example. And, of course, we can support lots of things beyond SAN environments. And you'll see we're starting with a nice, empty, clean directory. Now, I'm back on my shell session. I'm going to do a little bit of setup work on ZOS. Probably the most important thing is I'm going to connect my mainframe to that folder that I just created. And this is done with a normal mount command. I can specify whatever file system name I want. That's just a logical name that ZOS is going to know this file system by. And, as I mentioned, it's NFS. So I'm going to specify that. I'm going to specify that I want read-write access. I'm going to specify where it appears in the ZOS file system /mount/NFS. And that parm is everything needed to connect. So my IP address and the name of the folder we just created, volume1/shared/FlowZ. A lot of ways this could be done. This is just one example. You can automate this with FlowZ so that it happens under the covers every time a file is accessed. Totally up to you. Just showing this is kind of a simple way to understand what's going on here. So I've got my mount command, and I'm going to enter that command, and fraction of a second later it works. It's authenticated me. It's done all the things that our NAS device wants. And if there are any questions, I can use the display file systems command. And I see /mount/NFS has a file system called FlowZ mounted on it and some other statistics. So with the mount point created, now I can use FlowZ to create what I think of as a pipe, a local file system object on ZOS that's going to connect ZOS to that to that SAN resource that we just created. So I enter the command. You can see the output here. Nothing complicated. What I've done is specified the local name, the pipe file. That's the name that I'm going to reference the storage through. And I specified a target. In this case, it's a static target, but it doesn't have to be a static target. It could be a dynamic thing. Think almost like a GDG, that the name changes every time it's accessed. It might have the username, a date, whatever you need to be connected to it. And I see, where it is, and I see that the creation of the object worked. If you ever have any doubt, we maintain the status of all of this. So, we see, FlowZ status will show us what we've created. If we've actually accessed data there yet, we would see byte counts and all of that. So I'm going to do a really simple thing. I'm back in a TSO session here, and I'm going to use some JCL to copy a little bit of mainframe data to that link I created. So I'm running, nothing even proprietary from us. I'm running the standard IBGen or IBM utility. My input is what you see, hello from ZOS, and the output is that object that I just created. So I submit this JCL. It runs nearly instantly. And now I've got data back on my SAN environment. Now let's go look at that. Back on the SAN desktop, I'm going to head back into the File Explorer here and see what we have. So again, this would look a little different depending on the kind of file you create. In this case, I open up, I'm still in that FlowZ shared file, and I see what we did. I see an 80-byte file called my file, and that's exactly the data that we sent to it with that JCL. You can see the properties, you can see the timestamps, security information, all of that is visible at this level. So, if I had another application, let's say running in the cloud that needed to reference this, that data is there for him, bit for bit. It's the same as what we put into the system with JCL in this case. Certainly, I could do it in a lot of ways. I could do it with command line functions. I could do all sorts of things. So, we've created I think of it as a trivial amount of data. Let's look at something maybe a little more complicated than that. What we're going to do now is we're going to create, same process. We're just going to create a different file. We're going to create something, and then we're going to take a system backup to this target. So I'm creating a pipe here called my NFS dump, and I'm mapping it to my dump on my SAN device. You can see the results, same thing that we looked at before, just different names. And now I've got that object. So I'm going to go back again to TSO, and in JCL, I'm going to run IBM's DFDSS dump restore utility. Now, to make this work best with FlowZ, there are a couple of small JCL changes we make. First of all, instead of running the normal program name, we change that to FlowZ DSSU. It's basically just a small API example using DFDSS where we can load DFDSS and execute it through FlowZ, which allows us to capture the output and redirect where we want it. In this case, you'll notice I have a step lib. I mean, that's totally up to you. I mean, you as part of the install, you'll see how in the README file you would create this program. It's just running a link edit job. But the key is that I create a special DD statement, FlowZ dump, FLZ dump. And I point that, again, just like we saw with IBGen, I point that to the dump that I want to create in the network attached storage device in this case. Beyond that, it's just standard stock DFDSS. If I wanted to, I could write the dump in parallel both to a local file, maybe I want to, I don't know, a virtual tape or whatever else, as well as in the SAN device. I absolutely could do that. In this case, I'm just using DD dummy because, frankly, we don't have the disk space to hold duplicate copies of the dump. But the control statements, we're taking a disk volume called B3 Res 1 that happens to be a 3390. We're going to take a full volume dump of it, and we're going to use the hardware compression feature on the system that I'm on. And again, all of the DFDSS control statements, everything about it is exactly the same. It's just that
we ask you to change the program name so we can intercept some of the I/O that would normally go to tape or whatever it is. So I submitted that JCL. We can kind of watch it run. I mean, this is a 3390 disk volume, so it's, in the order of a couple of gigabytes. We can see it running here. It's chugging along. It's doing its thing. We can see thousands of IOs per second being issued here. And and we actually can look at the output, and just to confirm what I said before, you'll see the bottom half of the screen shows just standard DFDSS, and that's it. It's done at this point. In our testing, we find that a 3390 disk volume can be dumped to our SAN device in about a minute and 20 seconds. If I look at the output here, I see exactly that. I see a minute and what is that? A minute and 24 seconds. So, and again, keep in mind our development environment is a very small, very, very limited system. If I toggle back to the SAN desktop, I see the dump that we just created. I see that it's 1.63 gigabytes written in the time that we were looking. And again, I want to be clear, we're running on a Z PDT system. That's basically ZOS running on an Intel hardware processor, a desktop PC. The SAN environment we have is a little baby thing that we do testing with. It's not like industrial grade anything here. So, we did dump that 1.63 gigabytes in about a minute. And it is exactly what we expect it to be. I could do as many of these, as few of these as I want to. So, that's the quick version of the demo. You've seen, what we support in terms of targets. You've seen how to use it, how the installation works, and maybe even gotten a sense of the performance potential here. We look forward to hearing from any of you. If you have any questions at all, want to see different demos, have a technical conversation with us, by all means, don't hesitate to reach out. Thank you.
All right. Awesome, Vince. Thanks for putting that demo together for us. I'm going to jump into pricing here a little bit. So if you're familiar with our pricing model, we have very low barrier to entries and very similar to PropelZ. This has a flat rate. So $50,000 per year for your entire enterprise, as many copies as you want, etc. So very, very low cost access to get into this. You have to bring your own storage, but at least us enabling it to your cloud, your SAN, avoiding additional mainframe CPUs, DASD, etc. It's a very, very economical capability. So yeah, hopefully that's something that is pretty compelling to you. Vince, you touched on our other products here. And so, across our portfolio, we can handle just about any mainframe data access condition or use case that you have out there. And so, if it doesn't seem apparent here, reach out to us and we'll be glad to talk through it. We have some exciting announcements coming up on PropelZ as well, so keep your eyes open for that. And then I'm just going to put a plug in. We've got tons of resources. We have a very, very extensive blog on every topic that you can imagine. We have thought leadership papers as well. Each of the products has demos that you can watch, and more than one in some cases. All of our products are available for evaluation at no cost. And so, and I mentioned, our Skyward Data podcast, that has some really great guests as well as product overviews, all our webinars. So check that out on any platform, any preferred podcasting platform that you may have. Vince, anything else you want to share with us today, or we can wrap it up?
No, I think we are good to go. I mean, that's an exciting topic and a lot of information.
Yeah, sorry we went a little long on this one, but we wanted to kind of cover this as comprehensively as we could within this hour. And yeah, if you have any questions, just reach out to us, hello@virtualzcomputing.com, and we'll catch you on the next one.